Welcome back to the workshop. We've got another example for series where we want to determine if the series converges or diverges, and if the series converges, we want to find the sum. For this example, we have the sum from 1 to infinity of 1 over n times n plus 1. Now, to determine our convergence in this case, we're actually going to want to use partial fractions. So we're going to take this one fraction and rewrite it as the sum or difference of two fractions having denominators n and n plus 1. So by partial fractions, we find that this is equal to the sum from n equals 1 to infinity of 1 over n minus 1 over n plus 1. You may need to review partial fractions in order to find this, and that's quite all right, but you'll notice that if I were to add these two fractions back together, or subtract rather, then I would find this fraction. All right. So I have this representation of our series. What I'd like to take a look at is the nth partial sum. So consider the nth partial sum. Now the nth partial sum is simply the sum of the terms, the first term through the nth term. So the first term in this case is actually going to be 1 over 1 minus 1 over 2, right? Because we're starting at n equals 1. So we have 1 over 1 minus 1 over 2. And then we add to that, for n equal to 2, 1 over 2 minus 1 over 3. And then I can add to that the third term. Let's see here, 1 over 3 minus 1 over 4. And then I need a little bit more room here, so I'm going to drop down the line, and I'm going to add the last two terms. So for n minus 1, this is a little bit weird because we're using n here and n as our subscript, but we're looking when n is equal to n minus 1 and then when n is equal to n. So for n minus 1, we would have 1 over n minus 1 minus 1 over n, and then finally 1 over n plus 1 minus, 1 over n minus 1 over n plus 1. Excellent. So what we want to notice at this point is that there are some cancellations. So we have 1 minus 1/2 and then plus 1/2, so our 1/2s cancel out. We have a minus 1/3 plus 1/3, so our 1/3s cancel out. And we would find that the second part of each term cancels out with the first part of the next term. So minus 1 over n plus 1 over n. And we get that the nth partial sum is equal to 1, let's see here, plus 1 over n, 1 minus, right, 1 minus. 1 minus 1 over n plus 1. There we go. That looks better. So if this is our nth partial sum, then we can find the limit, or find the sum by taking the limit. The sum from n equals 1 to infinity of 1 over n times n plus 1 is equal to the limit as n goes to infinity. Again, the subscripts aren't referring to necessarily the same thing here. Maybe it would have been better to use j or k for our series and let n refer to the partial sum. So limit of 1 minus 1 over n plus 1, and this is equal to 1. Because as n goes to infinity, this quantity goes to 0. So that gives us exactly the sum from n equals 1 to infinity of 1 over n times n plus 1 is equal to 1. Excellent. So we have found the sum. It converges, and we found the sum. Here we may have concluded thus the series converges. because we found that the limit of the partial sums is finite. It exists. And that allows us to conclude that the sum is 1. And then the last comment that I'd like to make is this is called a telescoping series. Telescoping series. Of course, you can think of a telescope where you're looking out, and then you have your telescope that you can squish back down and put in your pocket, right? So here, in its expanded version, we had 1 minus 1/2 plus 1/2, and then the telescoping action of shrinking, we have a large number of cancellations. Excellent. More examples to come. See you guys back in the workshop shortly.